So, welcome everyone. This is our final seminar of the fall 2022 semester, and it's my pleasure to welcome Dr. Hector Escobar, who's currently a section manager for the Autonomy and GNC department at Aerovironment. Dr. Escobar earned his Ph.D. at the University of Maryland, College Park, where he conducted research on bio-inspired technologies for small object detection applied to multi-rotors. And before that, he got his MS from the University of Texas at Austin. And he will talk to us today about AV autonomy from concept to application. We will save questions until the end, but feel free to write them in the chat or just speak up when we're ready for that part. So please take it away, Hector.
Thank you very much, Mark, for the introduction and for the invitation. I'm really glad to be part of your talk series. And today I'm going to be talking a little bit about how we go from some ideas into actual applications, industrial applications. And as Mark mentioned, I'm part of Aerovironment. I'm not sure if you all know what Aerovironment do and has done in the past, but Aerovironment has been in the market pretty much for about 50 years when it was founded by Paul MacCready. And so I'll go over some of the things that you might be familiar with. Inside Aerovironment, please, thank you. Inside Aerovironment, there's different sections. So I'm part of the Autonomy Center of Excellence inside MacCready Works. And MacCready Works is the side of Aerovironment that is looking into innovation programs, new ideas. So these are some of the ideas we've come up with in the past. Going from like some of the newer ones back, you can see that we were part of the design of the Mars helicopter that it's actually now in Mars. We have a little replica in the office that we use for demos, and we fly around where we modify, let's say, the autopilot, because up in Mars, you know, it has to go a little bit faster. Also, you might be familiar with the Hummingbird in 2011. So it's that little bird looking like flapping vehicle. And there's some other ones that you might have seen in the past. And a lot of these artifacts are in the Smithsonian in Virginia. So we've done a lot of like innovation things in the past. But now, actually, I want to talk a little bit more about the future, right? And what some of the things we've been working or been looking into, right? So here on the left, you can see the Gartner Hype Cycle for Emerging Technologies, and this was from 2019. And some of the areas that we kind of focus are, you can see here in the red squares, the flying autonomous vehicles, and that's showing that the progress is going to be, or the peak is going to reach in more than 10 years. Also Edge AI, and that's going to be between 2 and 5, and the autonomous driving level 4. So that's full autonomy, for example. It will be also more than 10 years. But some of the applications that I will be showing you are showing that we're already past the peak. We're already in a good shape. We're already implementing some of these technologies currently, which can correspond to the timeline, right? But we're a little bit ahead of that. So when we talk about autonomy, there's a lot of different ideas that come to everyone, right? Like there could be different levels of autonomy. But the primary goal is for us is to coordinate a set of different vehicles to achieve mission objectives. And that is enabled by single vehicle autonomy. So basically you have multiple vehicles, single vehicle autonomy working all together, and then they can be part of a team, and such that an individual is controlling the team and not just individual vehicles, right? So here on the left, we have different vehicles we currently have, and that work at different levels of a whole system, right? So we have like high altitude UAVs, we have low altitude UAVs as well. We have some UGVs, and also we have fixed network of sensors. Right? So the idea is that we want to coordinate and communicate all these vehicles such that they participate as a team. So here I'm going to be showing you one of our capabilities and products that already is in the market, and is a vehicle in GPS denied and comms denied environment doing a mapping or survey mission. So hopefully you guys can see this. I'm not sure you're going to be able to hear it, but hold on, let me see. If you can hear it, well, I'm glad. So basically this is our basic Puma, well-known vehicle. It's flying around, and eventually the vehicle will go into a state where there's no GPS, but it will still be navigating. And it is basically, it was flying the intersection of that little square there, and then you can basically get the data out, plug it into a computer, for example, and then use that data to create a 3D rendering of the environment. So that's one of the applications, for example, where we put GPS denied plus survey, and then we can create a 3D map of the terrain. Here you can see the result. And that's done in a couple of hours, for example, depending on the size of the area, but that's one of the capabilities. Some of the future capabilities that we're developing are multi-vehicle evasive object tracking. We will have a couple of vehicles detecting an object, and we will be following that object with different views and from two different vehicles. So that's basically using multi-vehicle communication, object detection, and communications, as well as some of autonomous algorithms. Also, we're using autonomous obstacle avoidance so that we can keep the vehicles in a safe zone. So the two images are from two different vehicles, and they're showing how whenever one loses it, the other one is still like detecting it, and they share information in case one loses the other track. And on the left, you can see they're following it in the map. And both aircrafts are running object recognition on board. All this is happening on board, and they're just sharing communications. Another application that we've tested is wildfire monitoring and response. We did this in April 20. And this is just to show how we can use all these different vehicles. Again, we have the Puma here flying. This is an ATAC developer build that we have. If you're not familiar with ATAC, it's an Android app that you can use, and you can display vehicle information and waypoints. So now we're just setting up the mission, creating the area that we want to investigate. So the vehicle is flying around in this area. There's no smoke, it's searching for smoke. So as you can see here, that's where the initial report of fire was determined. Our video is looking around for any signs of smoke. And the second, you will see that the smoke is turned on. And this is just to show how different types, we can detect different types of objects and use that information for different scenarios. Now we turn on the smoke generator. And this, just to reiterate, this is done on board and it's all done autonomous. So here we're mapping the perimeter of the fire. We detect the fire and the aircraft begins approaching the fire. For this, we're using LWIR and EO to do the determination of where the fire is coming from. And you can see here we detect the thermal area, so we're adding it to the map. And then we display the fire in the ATAC device on the left. That's just also for human interaction. So here, I'm going to show another application. And this is, we're going to be detecting different objects, for example, a person or a car. And this is done with features. So you can see how there's a little dot in the person and there's a number, there's the detection number, and the bar usually denotes the confidence. And this is up from a vehicle flying high, and then we're tracking this object. And spotter edge is our detector, and it's running on board, and it can control the zoom level and the viewing angle. You can see how it continually keeps the track number, and that's showing that it's holding on to that point. Here's another example. You will see that this is a funny case where this donkey is in the way and is detected as a person. In one of the frames you see there. So even when they're trying to be evasive, we continually tracking. And the red square means that it's, even though it's detecting something else, it's set to follow the one that's on red. And this is all done autonomously, right? It's all integrated, all closed loop control. And even though it's detecting two objects, it's tracking a single one. Okay. This is another application where we are integrating a little bit more closely the ATAC MPU5 radios. I'm sure if you're, it's a mesh network radio. And we're controlling, for example, the gimbal and the camera and the video stream. It's all done through the MPU5. Additionally, we also have autonomy on board, as well as all the spotter edge detections that you saw before. And this is basically all integrated into an ATAC device, enabled device, and where you can select an area, for example, and say, well, I want you to search or map this area, just like you saw at the beginning. Can you guys still hear me? Just okay. Again, do the same, all integrated like the mapping mission that we showed before, and generate the mapping on the spot. And again, you can also do the object tracking from the ATAC device, which is pretty similar of all the pieces that I was showing you before, but it's all integrated into a single system. You can see here how we are tracking this car. And it is also, the tracks are displayed in the map on the left. So what's the future vision of the autonomy that we are thinking is where we have multiple levels of information flowing. The initial missions that we have is what I just show you, where we have mapping, survey, inspection, expeditionary scout, expeditionary overwatch, an autonomous search or autonomous teaming. And we want to be able to bring all that information down such that it's used at different levels. And again, we also want to have this working on GPS and comms denied. This is just basically what we've been doing. So Aerovironment delivers robust operational autonomy, which is what we've been just showing you. And now I want to talk a little bit about a little bit more in depth of the detections and what's driving our system on the AI ML side. So not so long ago, Aerovironment acquired Leap, which they're experts in the area of ML and AI. And with that, we were able to do a lot of the things that we've been showing you. So they wanted to be agnostic, so they can work in any video, for example, EOIR or LWIR, for example, support different types of imagery from recorded full video, live video, or streams from any source, and support mixed mode, which means have edge processing, which is processing on the device that it's flying or moving around, or a central localized processing, right? So the system is able to just grab that information and send it down. We also wanted to integrate this easily into other solutions. So now we have an API that could interface with different, for example, vehicles in a very fast manner. And then there's a lot of wide of analysis tools that go beyond just showing boxes of the images, right? As I was showing you the features that were plotted on top of the person in that case. As I mentioned, we want this system to be platform agnostic so that we can, like, clearly we can put this on board anything. And these systems and services, like the microservices, enable multi-scale processing, object ID tracking, geo-registration, which is basically putting it on a map, some analysis tools, multi-platform integration, autonomy integration. And with that, we can actually task and coordinate multiple devices or units. Also want to mention that the way we're collecting imageries, and you guys know this, usually or sometimes you have very limited information of the things that you want to detect or train your system. And what we've been also doing is using synthetic data, and that has shown to be very important because that adds not only the variability, but you can train your system with different environments or different sets that you wouldn't have access to, right? And that fills in the gap between the real data, but it's very important to mix this information. So for example, here on the left image, we have like how the real data looks like. Then we can generate 3D corresponding models. And then with those models, we can generate synthetic views with varying pose and backgrounds. And then we fuse all that information, real and synthetic. In the end, we're able to get good results for detecting. This is an example of how our pipeline works. For example, we get a request for detecting a new object. We have some basic few images. We gather initial amount of data. We manually annotate the information. Then we run it through a deep learning pipeline where we also add synthetic imagery. And then we also run it through a loop for self-annotation and retraining such that the annotations get better. And then we can get models within, let's say, as little as 2 weeks with this mechanism. One of the things we're also working on is on the re-identification. So for example, in one of the videos that you saw the number on top of the object. But if for some reason that object goes out of view and then comes again in view, you most likely, or most of the algorithms will detect that same object as a new object. So what we're trying to do is make a way such that if the object gets out of view and then comes back in view, we can identify that is the same one, right? So what we're creating is some sort of fingerprint for a unique object. And the way it works is that it's something similar to face recognition, but for the whole object. And then we can learn invariant features across the space and time. So even if it's going through some time. And we can also do online learning, and we will update the fingerprint over time. And that basically enables handoff between, for example, two vehicles that are tracking the same object. They can just hand off, instead of handing off like a square or an image tile, you can hand off those features, right? You can also fuse and correlate with different sources, like you're using IR or different sources of detection. And you can also change these detections as well. And you can accumulate them through time so that you can have what is called the pattern of life, right? So if you have something, let's say, moving at a certain way, or you can keep tracking that. And these images just basically describe, you have the images, and then on the middle one, you have like the fingerprint-like features, and then you can identify the one you're actually interested in. So what you can also do with that is some sort of filtering, where on the top left image, we have just the vehicle, generic vehicle detection, but we have different features that we can identify. You can say filter just for trucks in the top right. You can see the blue truck detected there. Same on the bottom left, you have just the general car detector. But then if you look at the bottom right, you can filter again just for trucks, and then it will show you which ones are the ones we're interested in. So on some of the videos, I show you that some of the persons have some dots on them. So that's because we're sometimes using key points of the features. So then that allows us to identify parts of an object, right? Not just the bounding box, but it allows us to say, well, this is an arm, this is a shoulder, and so on, right? I always tease about like those, like the kids song, right? Which I forget now. So that allows us to have a higher fidelity of detection and tracking, right? These are just some other examples of detections that I'm just not going to go through. And I think, I know I'm a little bit short on, but I think there might be a lot of questions. So, Mark.
Yeah, no, thank you. I think it's very interesting and nice to leave some time for questions. It was maybe I'll start with one, and then we'll kind of open up the floor. You mentioned in a lot of your examples the importance of navigating without GPS. Maybe could you give just some high level background on why that is important, relevant, and maybe some of the different techniques that go into that. I know you sort of mentioned some of them, but maybe there's other sensors and things that are also involved.
Yes, so well, the importance is that we are so used to having GPS anywhere that we don't really think of it anymore. But there's been cases where just a simple drop in the GPS around, let's say, an airport completely stops all the movement. So we have to be always thinking ahead of the what if we don't have different mechanisms that we're used to, right? So for example, well-known algorithms are like the visual inertial allometry, where you just base your navigation on visual features. We also have, for example, you could be flying with a laser pointing down, and then you can match that to your terrain map. And that's another sort of navigation, also GPS denied. So those would be some of the ones that I would say they're very important. And there's some others recently. There's a lot of research on magnetic navigation, which basically, you imagine you have a magnetometer on board, and mostly all of us have, but then if you have a map, a pre-recorded map of the magnetic field below you, then you can actually position yourself in that map. So that's another topic that I'm interested in, pretty much. And recently we heard there was also some research done with trying to use the stars, and that, I mean, that's already done in space, right? But from the ground it's a little bit harder. But that's again another method of GPS denied. If you have, again, you can see the stars and then you have a pre-map of the stars, then you know where you would be, right? So those are some examples.
Yeah, that's how they used to sail around the world, right, before electronics, right? So
exactly.
Yeah, no, it's very strange. I think you hesitated to say, but I can say it since I don't have any security clearance at all or anything, that GPS signals come from satellites very far away, like 40,000 kilometers away. So you can imagine how weak the signal is by the time it gets here and how easy it is to interfere with it. So there's a lot of situations, as Hector mentioned, where even intentionally or unintentionally that signal can be interfered with. Okay, very any other questions or any questions from students or anyone else?
I kind of have a ton, but I'll start with just a couple. What kind of hardware do you typically run on board for edge deep learning processing in inference?
So, for example, we've been using from FPGAs, but most currently we've been using NVIDIA devices.
Okay. And like FPGA, are you actually like programming models to FPGA or just designing ways to interpret layers faster on FPGAs? I work in like computer vision, so this is similar but different. So I'm intrigued to know what you can and can't tell me about how you approach it.
Yeah, I cannot go in too much detail, but yes, it's less what we can do on the FPGA, as you know, just because a lot of the designs have been done for GPU processing. So yeah, it's definitely less what we can do on an FPGA than what we can do on a GPU. But I mean, we've been able to run a lot of like the commercial off-the-shelf algorithms on board. And for example, some of the very heavy computationally ones, you just have to make sure you run them not as often, right? But then you have to adapt to the output.
Mhm. And then another one, path planning is kind of tricky. So with something like this, do you give it a box to explore? Is it just scrubbing like a Roomba? Like what kind of how autonomous is it, and can it like creatively explore, or is it just kind of rigid?
So it depends on the mission objectives mostly. But let's say we have the option to pretty much tell a vehicle, well, yes, just fly the normal lawnmower pattern, or do a spiral, or do this and that, like already predefined, let's say. But they do have the ability to say, well, there's going to be an object there, so I have to avoid that mountain, for example, right? For the multi-vehicle, since we're doing a lot of like development and research, we tend to not want to crash them anyway, so we separate them from altitudes. But we do have the ability to put like higher level algorithms, like path planning algorithms. So it's all depending on what we want. But yeah, we have the option to say, to use basic, just lawnmower, that kind of algorithms to make it just replan on board, right? So for example, for the multi-vehicle tracking, they have to be replanning on board while they're looking for the evasive object. Thanks.
We have one question in the chat about power management. So how much time in terms of refueling is required for the vehicle? And since there are a lot of electronics on board, how is it managed during critical situations?
So when we are designing the systems, we have to take into account like how much more of the stock vehicle we're going to be using, right? That goes from weight, power, size, and then adapt the missions to account for that, right? So pretty much the vehicles are internally detecting if the batteries or it's all, they have a protocol that they would follow in case there's a low battery, right? So that's all taken into account once we're designing the system, once we're adding autonomy as well, right? I don't know if that answers.
It's mostly battery. Are they mostly battery powered, or lithium-ion batteries, or what's the?
So some of the ones that I showed on the videos, yes, but AV has some other ones that do run on fuel. Some helicopters, I believe.
Questions, and I know your colleague Brian Morrissey has maybe some wanted to specifically say that you guys have some openings for internships and things, right? So
Sure, I could introduce myself there real quick if I'm taking over.
Yeah, please do.
So my name is Brian Morrissey. I'm one of our engineering department managers, specifically for autonomy and GNC and systems engineering. I've been at Aerovironment for 13 years, and I've gotten a chance to work on a lot of our different products, and it's just been a really great experience. Aerovironment has like so many irons in the fire. Like we're making high altitude, solar powered, stratospheric airplanes that are just a big flying wing. We're making small hand launched drones. We're doing, technology development with autonomy for, places like DARPA, and we have products that are missiles. I mean, it's a really great variety of cool stuff to work on. Oh, the Mars helicopter, So to that end, I did want to mention we have internships open for next summer. And that's kind of why I'd asked about the background of the, you know, the students here in the seminar. And so I'd encourage people to take a look at the listings. We kind of have like mechanical engineering, electrical engineering, software, GNC. We have a lot of different types of internships open. If you do want to apply to those, there should be an area for like notes or like reference. Maybe put a note in there that, you know, you were in this session here with Hector or myself, or just put a note in about the school, so that we can try to track that down. But yeah, so thanks. So Hector's been a great part of the team, a great leader for us in helping to build out some of these autonomy capabilities. And yeah, this chart shows some of the history of the wide variety of things that AV has done. And this is only like really like the top 10% of what we've done, all the stuff that's in this. But yeah, I would love to hear any more questions about either this content, the company in general, or, you know, what we're doing with our next generation of robotic systems and autonomy.
I have a couple questions. One, we kind of phase in and out of having courses here. Like, so one question is, we've worked, and by the way, everyone, we've worked with Hector before on a DARPA project before he was with AB. But like, what kind of course should we have like in the future at, say, CU Denver between our departments for autonomy? Because that's something that we're actually looking into. And even if it's not a course, what kind of training can students do on their own in independent courses or certifications that may help them get jobs in this industry?
Hector, you got any input on that? And if I hear anything, so, yes, I know, right? So I have a couple of recommendations. Let's say, I think, of course, programming. If you guys like programming, that's a big plus for us. Either Python, C++, then Rust 2, machine learning courses, or if you're focused on machine learning as well, we're very interested. Controls. From GNC, from estimation, common filtering, these kind of things. We're definitely want to hear from you if you guys have done that, and even more so if you had put a lot of all these together, right? Because a lot of the times, maybe the course where you just say, well, yeah, I put a common filter to the simulation, but then we actually implemented it in an actual vehicle, then it's another level, because it gives you actually the hands-on experience of how you need to tune it, or how you need to change something that you wouldn't do it in the simulation otherwise, right?
Yeah, I would just mention, you know, there are a lot of good online courses these days for autonomy related disciplines and areas. We engage with those things for our staff, you know, people that work for AV. We want to encourage like ongoing, like learning new things and practicing and sharpening your skills, because you're not always doing all the things that are in the spectrum of this technology area on a given project, right? Sometimes you're focusing on one thing. So, you know, there are, you know, online courses. I think everything from the perception side, so sensing, sensors, maybe dev kits and little projects about different kinds of sensors and state estimation, and how do you fuse data from different kinds and sources of measurements, through to, you know, how do you make plans and react to that information and use that information, and then, you know, down into control systems and how do you act to put into place those plans. We look to, when we're trying to build our team, we're looking across the board to people that may have worked in autonomous vehicles or ground systems, but also we really love people that are getting out there and doing exploration with UAVs, because it's a different, there are a different set of challenges that come from a flying, you know, robotic system to a ground-based robotic system. So that would be, you know, some of the input I have.
If you guys could send us a list of those online courses, you know, that'd be great after this.
Okay.
And to follow up on Ron's kind of, you know, curriculum professor question, do you think if students want to get into this area, is it best to kind of focus your skills, or is it best to maybe broaden your skills and perspective? And I know the answer is always both, but specifically, is, for example, like a master's degree in system engineering something that can really strengthen your resume in terms of working in robotics and autonomy?
Yeah, I think there are a lot of paths to success in this discipline area. I will say, when we build the team, we're looking for people who have broad experience and systems level thinking, as well as people who are, focused experts and have that expertise. So there is a place for, any model, whatever people feel most motivated by, most comfortable with, I think is the thing to do, because ultimately, when you're pursuing, for the individual students, when they're pursuing something that really is aligned with their own motivation, that's the way to be most successful. In terms of curriculum design, my opinion is that having the ability to kind of touch a lot of pieces of the system and of the different disciplines, but if you want to dive deep, I mean, you can dive deep into path planning, you can dive deep into embedded software systems, you can dive deep into, machine learning. We touched on a lot of that. There's a lot of machine learning behind the scenes happening in what Hector shared. And we kind of have a team on our company that's doing that work as well. So there are a lot of different exciting areas to get into, but I don't want to minimize the aspects like designing the actual vehicles themselves. So there's an element of all this that is, you need the aircraft, or you need the ground station, you need the network, you need the operating system, you need all these building blocks in order to be able to create and field and deliver. That's your tagline of this presentation, Hector, right? Is putting it into action, right? You need all these different pieces. So you can be a team member supporting this kind of exciting work, I think, in a lot of different areas. Sorry to cop out on the answer.
No, that was very nice, broad perspective. Any other questions? I'm sure some more of the students have questions. They're just being shy, so please don't be shy, or else I'll just keep asking questions.
And the other thing is, if any of those videos went by quickly, and you wanted to see more, just chime in and we can go and replay them. Sometimes there's a lot. It's like a overload of things.
It's on purpose.
Sure. Let me ask one. I got the feeling a lot of your videos and applications were sort of military user oriented. I was struck by the Gartner hype cycle. I hadn't heard of that before, and that looked very interesting. Could you maybe comment on autonomous driving, self-driving cars, where we're going to see them? Because that was something that I think 5 years ago, people said we'd have it ubiquitously now. I read an article a month or two ago that said sometimes these, companies like Google, Tesla, and others the cars have problems with simple things like an unguarded left-hand turn. We have to yield to traffic, right? They're great if you get the yellow arrow, if you get the green arrow, but once it's like you have to yield, the system breaks down. What are your kind of just general predictions in that more civilian kind of space?
And any Elon Musk bashing you want to do, we're open to.
I do believe that we're getting closer. But I would say still within 10 years. I don't think it's going to be less than 5, because we're not, let's say, all the autonomous things need to go through the legislation, which is one of the main blockers for a lot of the technologies that we want to test, right? So maybe we will see autonomous vehicles somewhere else, in some other countries where there's less regulations than first and than here, but that's just my opinion.
So do you think that things like the challenging left turn it's not really, you're saying, a technology issue as much as maybe maybe safety margins and regulations more?
Yes, I think so, because the thing is that basically all those are corner cases, let's say like the left turn, right? And that's basically the one that was on the slide. So there's like little minor corner cases that need to be explored. And then once they're explored and there's a solution, then you can say, well, this is just a single case. We need to treat it differently, right? Like when Tesla had the issue where it was detecting the bridges as something and then it will break, right? So they're just corner cases, right? That even for us, sometimes when it's far away, it's hard to see what's there, right? So I think I see more the issue of the legislation, I would say, than the actual vehicles. Yeah. I don't know. That's my point.
How about hydrogen fuel cells on drones?
Right.
Sounds like a bad idea to me.
Well, there's interest there. We have, so, you know, actually, yeah, so this slide that's up is a good example because MacCready, you know, Paul MacCready was the company's founder. MacCready Works is the division of our company that's kind of focused on a wide variety of technologies that we can incubate and develop, as opposed to like supporting us one specific product line. And there is you know, there are some folks within MacCready Works at our company that are looking into that. We've actually gone and done some test drives in some of the new hydrogen fuel powered cars. Isn't who is it? I'm gonna get the manufacturer wrong. Is it Ford that has one out right now? But
I think Toyota has one called Milan, and also Honda has one called Clarity. Yeah.
yeah, so we've done some exploration there, and ultimately it's an area we are interested in as Aerovironment. We have a past history of exploring fuel cells and alternate fuel solutions, because if you can run off of hydrogen, either, you know, compressed hydrogen gas or liquid hydrogen, your energy density is huge, and that supports a lot of the kind of you know, long-term missions and sensing missions that we have in our history. The challenge is always the power output, and you can see some of the vehicles on the left and the top of this chart. One of the common elements in the design of those vehicles is ultra low power to weight ratios, right? So, you know, how do you build an airframe that can be powered by a human? The power output, you know, generated by a human. The bottom left is, you know, solar power, and one of the variants of Helios, in fact, I think the one that actually crashed over Hawaii, had a hydrogen fuel cell integrated to test. So it's been an area of interest for AV over the last 20 years, and there's been some new interest because of those technologies becoming more. I guess the TRL is raising on those in the automotive industry.
Brian,
so,
that
yeah.
was a little tongue in cheek because that's what we collaborated with Hector before. We proposed to DARPA for the subterranean challenge that we did hydrogen powered drones, but DARPA never got permission while in the 3 years that we could actually fly them in the
To
cave.
fly those inside, yeah.
Yeah, it's
DARPA
tricky.
did say
So
it was an area of interest, and one of the reasons they selected the proposal. So it's yeah.
my first job at Aerovironment was working on a vehicle that's not on this picture, but it was called Global Observer, and it was a fixed wing airplane. You know, took off conventionally, landing gear. You know, it had a 6 foot diameter tank of cryogenic liquid hydrogen on board in the fuselage, and wrapped in a layer of aerogel to insulate it. And we used the hydrogen boil off we burned it in an internal combustion power plant that we developed, ran a generator, and ran electric propulsion on the propellers of that airplane. So yeah, we're definitely interested in the hydrogen power plants, but you know, there's a lot of challenges: infrastructure, safety, transportation of the fuel. You know, there's a lot of challenges. But you know, with the automotive industry, if they adopt it more widely, that breaks down some of those barriers.
Okay, last call for questions for our two speakers. Okay, if not, let's thank them as much as we can in a virtual meeting, either clap or give a thumbs up. Let me Stop.
Thank you.
Stop